What if I told you scientists have found something in space that is not clearly a planet and not quite a star either? A mysterious object sitting right on the boundary of both. And thanks to the powerful James Webb Space Telescope, we're finally starting to understand it. This discovery is pushing the limits of everything we thought we knew about space. Welcome back to Universe Secrets. Today we're exploring one of the biggest questions in astronomy. Where do we draw the line between a planet and a star? And the answer might completely change how we understand objects in our universe. It's a question that scientists have been debating for decades. At first it seems simple. Planets like Earth, Mars, or even Jupiter are clearly planets. Stars like our Sun are obviously stars. But things get complicated when we look at very massive gas giants. Some of them are so large, they almost behave like stars. In fact, there's a whole category called brown dwarfs, objects often described as failed stars. They're too small to fully become stars, but too big to be typical planets. So the question is, where exactly is the boundary? And the answer isn't as straightforward as you might expect. The key difference may not be size, but how they form. Planets form in what's called a protoplanetary disk, a disk of gas and dust around a young star. Tiny particles stick together, forming rocks, then planetesimals, and eventually full planets. Stars, on the other hand, form very differently. They are born from massive clouds of gas that collapse under gravity until nuclear fusion begins. So instead of asking, how big is it? Scientists are now asking, how did it form? Because formation tells us more than size ever could. This is where things get exciting. Astronomers have discovered a strange gas giant object called 29 Cygni b. It's about 15 times more massive than Jupiter, right on the edge where objects start behaving like stars. This object was directly observed using the James Webb Space Telescope, one of the most advanced telescopes ever built. At first glance, its mass suggests it could be a star, but what scientists found next completely changed the story. The JWST analyzed the atmosphere of this object and detected elements like carbon dioxide and carbon monoxide. Now here's why that matters. These elements suggest it formed in a planet-forming disk, not like a star. Even more interesting, this object contains a huge amount of heavy elements, equivalent to about 150 Earths. That's something we expect from planets, not stars. This evidence gives us a completely new perspective on its origin. There's also something called the deuterium burning limit. This is often used as a boundary between planets and stars. Objects above this limit can fuse a special type of hydrogen called deuterium. And guess what? 29 Cygni b sits exactly on this limit, which makes it one of the most important objects ever discovered for understanding this boundary. It's like finding a missing piece of a cosmic puzzle. So what is it? A planet or a star? The evidence strongly suggests it formed like a planet, not a star. Which means the traditional way of defining planets versus stars, based only on mass, might be wrong. Instead, scientists are now focusing on formation history as the real key. This could change how we classify many objects in space. This discovery could completely reshape how we classify objects across the universe. And it also raises a bigger question. How many more in-between worlds are out there waiting to be discovered? If you're fascinated by real-time space discoveries like this, don't forget to follow for more updates from the universe. Because space still holds many secrets we've yet to uncover,